from your break, or you will join us in a moment. Now we will begin the second part of the first session, and we will continue exploring the issues of machine translation and of apps for speech recognition applied to the translation sector. In particular, we will have a contribution from two companies, Translated and Pervoice, followed by the presentations by two experts from the University of Mainz site and the University for Foreigners in Reggio Calabria. Before moving to the presentations, I just wish to remember to participants that you can type your questions in the chat, and we will then raise the question as soon as the presentation is over. Now, the first presentation of this second round of contributions will be held by Luca De Franceschi, who's a project manager at Translated, a company you're most likely familiar with. And he will cover a number of topics in his speech because he focuses on a number of issues. I just wish to add that Luca was a very smart student at our university, and he's a living example. I wish to say this for our students. He's a living example of the fact that there is life after college. As you can see, he's doing well and he does a lot of interesting things. He got his degree at UNINT in 2015. He was practically immediately hired by Translated, where he now works on a number of issues. You can read his bio, and you will discover more about his work in the course of his presentation. His contribution is entitled The Future of Automation in Localization and Audiovisual Translation. Luca, the floor is yours. Thank you. Thank you so much for your kind words. I am not sure I deserve them, but thank you. Now in this present, when you invited me, I was very happy, and I thought of what I could talk to you on the question that is at the center of the workshop. What is the state of play? I wish to thank Marcus Foti for his brilliant presentation, where he very well explained all the complexities behind the technologies that are reshaping the translation market, both written, the market for written translations and translations for audiovisual content. In my presentation, I would like to tell you something about how these technologies are being implemented market-wise, and then give you a little survey of some of the projects that we are working on. Because, as Professor Russo said, machines cannot take the place of humans, but we believe that humans need technological support in order to do their work better, because the amount of work is becoming so huge that a human being using traditional methods cannot simply keep up with the amount of work. And that's why technologies have become so important. So I will now share my screen. And I will make a very brief introduction, but I hope that then we can continue discussing these matters also via email, if you like. So the first product that we have developed and which is on the market already, and that's Modern MT. Modern MT is an MT neural engine, which is adaptive. Adaptive is the keyword for this product. Because I personally believe that machine translation has evolved massively, first with statistical MT and then with neural MT. And I think that neural MT can further advance as long as it becomes more flexible. Of course, this means being able to train an MT model so that it is effective. Now, the approach that modern MT uses is slightly different from other approaches, because rather than just relying on training, the engine adapts to the context of what it is translating, but it also adapts to the translation style of the translator. It does so by using three components: the memory translation, the translation memory, the context vector, and the adapter. These three components allow for the output to be adapted to the terminology used by the user. So at first the user uploads her MTs into the engine. Then once a text is fed to the MT, a new context vector is produced for that document. And in that phase, the engine makes queries inside the system, and so basically trains itself on the spot so as to adapt the output on the basis of the memory that it has acquired. And so it is capable of learning from the user in that sense. This type of technology has a number of advantages. On the one hand, the quality output is much higher compared to a standard MT. And the reason for this is that it is tailored, we could say, in order to respond to the user's own style. The costs are way cheaper because you don't have a startup phase, because adaptation happens in the moment when the user uploads a memory. And it is very easy to use. It is available as a plugin for many market products. And the fee for translators is 25 euros a month, so it is extremely accessible cost-wise. And so the benefits with respect to generic machine translation or to a statistical machine translation are countless, because sometimes a statistical machine translation can have comparable results, but at a much higher cost. Here below, you can see the link if you want to go on our website and learn more about our modern MT and possibly use it. Just to make a practical example, here you have an example that we've made on the basis of a number of tests carried out with human translators. We have a source content, we have the final human translation, and at the bottom of the screen, you can see the generic translation made by Modern MT as the baseline product and the adaptive version. And as you can see in this particular example, we have the final translation produced directly by Modern MT with no post-editing required. Of course, this does not happen all the time. Sometimes the result needs to be corrected or reviewed, but we are talking of a very high level. But once you add the adaptive feature, then your output is going to be way closer to the final result. Here we can see that 10-year bonds or closest available bond maturity is the final result. And basically we just have two changes at post-editing level, just with the word maturity that was added and with the number 10 being converted into a digit, and that is all. Of course, in the number of years, many tests were carried out, and we also participated to the WMT in 2018, where we scored second best engine. We were second only to the Google product, which was yet not a commercial product back then. We did not participate to WMT in 2019 and 2020, so unfortunately I cannot make a comparison there when it comes to the state of the art in the last 2 years, but nevertheless the result in 2018 was astonishing. And here we have a blind test where we showed a human translator the output, the Modern MT output and the Google Translate output, and the human translator did not know which was which, and we have scored very high. This product is available as an API, but also as a plugin for CAT tools for translators. And at this point, I would like to say a few words on our own CAT tool. Of course, CAT tools are widely known because since the development of Trados, they have entered the translation market as an essential support tool. MateCat is the CAT tool that we developed, and it's been on the market since 2013, 2014. And this project was financed by the European Union. Marcus will remember well because he cooperated into the development of this product. It was a pioneering product because it is entirely web-based, and it was also one of the few CAT. We immediately integrated the machine translation. Initially, of course, it was statistical machine translation, and now it's the neural one. And we also hope to make this native to the product. It is an interesting tool because it reflects a lot our philosophy at Translated, the idea that technology is there to support human beings in their work. And it is for free because we think that we shouldn't make profit out of technology. Of course, we have a business model where we sell our translation services, but we do not make people pay for technology in itself. You can access it via browser, Chrome, Safari, etc. And it supports the translator at a very advanced level. Also, thanks to its connection with my memory, which is a public memory that uses available public official documents in order to build itself up. And it's an ideal tool because, say you are a student and you wish to learn how to translate, even if she has never worked, so she doesn't have her own database, but she can immediately access a vast amount of contents that can help her improve her work. Of course, it supports term bases and many other features. And it's a collaborative tool. Unfortunately, I do not have time here to make you a live demo of the product, but I would be very happy to stay in contact with you. And if you wish to organize a demo, I would be absolutely available. As you can see, our interface is simple. And here what you see is a translation based on a public memory, but you could also see some suggestions that ModernMT selects in a smart manner. So making the best possible suggestion on the moment. If you have your own memory, it's going to use it. Otherwise, if you wish to use public memories, it's going to try and dig any possible suggestion out of that. And otherwise, it goes for the neural mode. And it is collaborative in the sense that you can add comments, or say you have a very big project and you need to share your work, that project, with a colleague, and you can both work with the same interface and sharing the same document. Translated often as a company has to deals with massive projects where we have a very short deadline, and we can do so because we have a collaborative tool. Another product which very well keeps together the ASR and machine translation is a project for which we have got some funding from the European Union, and in order to transcribe and translate the plenary sessions of the European Parliament. And that's very interesting for us because it is a way to make it possible to overcome the barrier of spoken language for people, for deaf people, or for those with a hearing loss. And so through this project, we will be able to develop a service that will make it possible to follow the European Parliament sessions and using the ASR to transcribe automatically the text and generate through ModernMT machine translation in all languages of the European Union. We are still developing the tool, but it will be made available as a web mobile app in the near future. What is interesting about this system is that it is not replacing the human being, but rather integrating the human being in the process in order to have increasingly better results. You will have a system where users will be able to provide their feedback on the content, and feedback will be used in order to improve the output. Finally, and here, I would also like to have a little demo at the end of the presentation. This product has to do with the growth of audiovisual content in the translation market. And as it happened with written translations, the market for the translation of audiovisual content is currently undergoing deep changes. It currently amounts to about $2 billion, and we have a growth rate of about 40% to 80% per year. And of course, if you just think of platforms such as Netflix, Disney Plus, etc., we have an increasing number of contents which needs to be translated. And this process can be time-consuming. And as in the case of what happened with written translations, I think that also in the case of audiovisual content, the role of the human being is to be the creative one, whereas automatic tools can support the human being on making the manual part of the work lighter and faster with a better quality. So we are developing Matesub. Matesub is a subtitling tool that is entirely cloud-based. And what you do is you upload your video, and in a single step, it will generate the transcription and the subtitles, so a spotting list, and it automatically translates the spotting list. So basically we are helping the entire subtitling process so that the human being, which in the past the human subtitler needed to use, let's say, 1 hour or 2 hours in listening to the content, transcribing it, preparing the spotting list, we try to reduce this time so that the human being can dedicate more time to being creative. Of course, we are only at the step of a beta version, which is public. So it is available, but not as a final product. But I would be very happy to share our beta version with you. We have some of the participants today that are interested, and we are trying to have feedback from professional subtitlers. And for them, it would be interesting to have a tool that they could use. Yes, Luca? I wish to tell you that, yes, we have a nice research project in our university on subtitles, and we would be very happy to test Matesub. I coordinate the project together with a colleague in the Northampton University and another colleague here at UNINT. Yes, I would be very happy to discuss this with you. So I would like to just show you how it works. It will be a very brief demo. Many of the features that we are planning to develop haven't been developed yet. In the future, we also want to integrate the tool with a term-based and machine translation mechanism. But now I will just show you how it looks. So I'll open this window, and this is a project. I hope you can see it well. I have zoomed in enough to see the entire page. I created this project simply by uploading a video, and I set the language combination, and all the rest, the machine did it. So I will let the video play. So you can decide what you think about it.
It wasn't.
No, this is a 1 minute. The video lasts 1 minute. I have just showed you the very first part. And all you have seen, Marcus is quite familiar with this project because we're working together on the project and is contributing in improving the phase when the spotting is generated. As you can see, the output is not perfect. The machine makes mistakes and it will continue to make mistakes no matter how hard you train it. But what we are aiming at is making all the manual steps faster. For example, this subtitle and the following one, they could have been just one subtitle, but we can do that. We can put them together. And we're trying to have a user-friendly interface that is both your working interface, but also your preview, where you can also have your preview. Now, I am doing a number of operations, which are quite easily, such as moving the subtitles, changing the time code. I can also use shortcuts. And I have some quality indexes available here, which say things such as dynamically, it points out to me that we have some problems. For example, I have too many characters per line and the subtitle is too high on the screen. So I will make my little corrections and I will have my final subtitle. And all this is thanks to the support the machine is providing. Now, we are still developing this product and we are extremely interested in having feedback from users. So if you are interested, please contact me so that you can try it out. And let us know what you think about it, because we always try to keep in direct contact with our final users. That is it. Here in the last slides, you can see that, of course, the beta version will be launched at some point on the market, but we are planning it to have it as a free account or as an account that you have to pay for where you have extra features. Of course, we're trying to be competitive with respect to other players in the market. And that is it. Thank you very much, Luca. We just have a couple of minutes for questions. Many questions were raised. I cannot go through them all, but you can take a look at the chat and perhaps if there are some questions that you will not be able to answer now, you could do so in the chat. Hendrik? Flemish colleague was asked if the best results that you showed for modern MT in comparison with Google are those results where they also achieved thanks to the integration with translation memories, or is it only thanks to modern MT? And then second part of the question is, could we access the data and Google the feature. So in the moment in which you upload your own translation memories, the machine, the engine adapts and you have a better output. Published data, I contact, of course, with those in charge within Modern MT, within Translated, and we can have an exchange on that. Yes, I see that the colleague is adding further questions on Modern MT. And he's not the only one. For example, other participants have asked if this neural machine translation can also be integrated with the Drupal content management system. It's a very specific question. Yes, they are all very specific questions. I think that I should reply via email. Anyway, it is available as an API, so it can be integrated with other systems. And formats, TMX is fine. So you can just upload your memories in TMX format. And Modern MT is going to learn from those TMX files. Then we have a couple of questions on MateCat and Matesub. A comment on MateCat saying it is extremely interesting. Make it accessible also on other drivers and on devices other than laptops. But congratulations. On Matesub, question, does it generate time codes? But I would say that you very well showed in your presentation that it does, and whether it works with Arabic at the moment. In the current version, Arabic is supported when it comes to speech recognition, but not for the time code generation. Of course, we are working on it, so we will get there for Arabic at some point, for sure. Then we have many other questions, such as, what's your opinion on the quality of Netflix subtitles? On this, we would have a huge debate, which is not particularly in the scope of our workshop, and nevertheless, we have no Netflix representatives here to defend their work. So perhaps we could organize another event also with content providers. So I would suggest to all participants having specific or technical questions to email Luca, and Luca can then put you in contact also with other colleagues within Translated who can answer to your queries. I'm sorry, but we need to stop here because we are running out of time. But thank you, Luca, for your extremely interesting presentation. And on the chat, you also have a message from Serenella Massida from Roehampton, which is the colleague who works with me in this research project on subtitles, and we'll be in touch. I will be very happy to stay in touch. And thank you so much for the invitation. Thank you, Luca. And now we have to move on straight to the next presentation. And so I would leave the floor to the second company that we have with us today, and Pervoice, and we have Gorizio Ciancarelli and Filippo Tessaro. Just a few words on both of them. Gorizio Ciancarelli is the client manager of Pervoice. He works on many things, but who all have to do with the sector of how we can digitalize speech, whereas Filippo is an engineer who works on machine learning. He got his degree very recently, congratulations, and he is already working with Pervoice and is currently working on the development of a system to translate speech in real time. So first, Gorizio will tell us a few words in general on Pervoice, and then Filippo will tell us about the specific project he's working on. Thank you.
Buongiorno a tutti.
Well, thank you very much. Good morning, everybody. I hope very much you can hear me well. Before going on, I'd like to ask you on behalf of my company for the invitation. The workshop is incredibly interesting because of the high quality of the guests and the enterprises, the institutions, and a huge number of students. So without further ado, since we are a bit behind schedule, I'd like to start my presentation. I'll get the ball rolling, first of all, sharing, or rather trying to share my screen. What is Pervoice doing? Well, we've referred to Leonardo. Well, the presentation isn't actually shared on the screen. This is one of the technical notes. Okay. Right, let's start all over again then. So what is Pervoice doing? Right, in a nutshell, and quoting Leonardo da Vinci, we could say that simplicity is the highest degree of sophistication. Pervoice is actually simplifying a rather complicated task by turning speech into text and extracting value. It is a real digitalization process, taking the speech to become text to the benefit of different users and in different contexts, as a matter of fact. Well, this is more or less the least of the topics that I will be dealing with. Actually, I will be presenting Pervoice to tell you about the successful use cases of ASR and MIT technologies. And my colleague, Filippo, will tell us about his own experience within Pervoice when it comes to real-time spoken machine translation. And of course, there will be a Q&A session after this. I am Gorizio Ciancarelli. I'm a client manager at Pervoice, and I'm responsible for digital projects related to services based on ASR and MT projects. We have media intelligence, media monitoring, contact centers, minutes of meetings, and so on and so forth. My personal goal is always the same. Well, my rather professional goal is always the same. Solutions that we implement are always for a greater accessibility of languages. And I'll show you some examples. Now, coming to Pervoice. Pervoice was created in 2007 as a spin-off of the Bruno Kessler Foundation of Trento. It's really the connection item. In a way, I heard the FBK representatives talking about the topic of this workshop. Today, Pervoice is a controlled company, controlled by AlmaWave, which is part of the AlmaViva group, developing enterprise software technologies for voice recognition with a paradigm which is natural language. Among these AI technologies, there's machine translation and ASR, which are managed by our company. Alma Viva is a very big company, 40,000 employees, out of which 10,000 are in Italy. It is a global leader, and it is leading the digitalization nationwide in different areas. Talking about Italy, of course. Now, going back to Pervoice, if we could imagine a value tree, we first see people as the root of the tree, and Pervoice is strongly and deeply convinced that technologies should support humans, whether it is in work or everyday life. In Pervoice headquarters is in Trento. There's a technical and marketing branch. One is in Rome, one is in Milan, covering the different areas of the country. Pervoice a solution like a help desk, activities, well, voice interaction and speech recognitions are an enabling element for the optimization of these processes, to simplify these processes, and of course, to enhance the quality of these processes. We cooperate with different entities. FPK is a constant partner for us, but I'd like to quote a couple of important partners, DVIs and Minsk. DVIs shares with us a number of aims, is a leader in media monitoring activities, and thanks to Pervoice, namely automatic speech recognition functions, UDI is able to monitor radio and TV channels in real time. So we're talking about tens of countries and tens of voices. Minsk is operating in the legal and public administration sector. And we help them with dictation, automatic transcription, machine transcription activities. But we also cooperate with a number of universities and and Disability Pride is also a partner for us. Pert Voice is particularly attentive to accessibility. Disability Pride is a network of bodies and companies that has a mission. The mission is to focus on disability of disabled people, and then our partnership encompasses, just by way of an example, the captioning of all the events of organized by Disability Pride. In July 2019, we've subtitled with the Pert Voice technology the Disability Pride of the year that was carried out live from Piazza del Popolo in Rome, and the whole of the content became absolutely accessible to all people, no matter of their disabilities. So what you see at the bottom of the screen are 4 sectors. Verbalization and dictation comes first, is the market share, which is like the natural turf for voice, so transcription, verbalization, voice dictation, and we also match that with machine translation activities and command and control functions and features. Media intelligence is a market sector whereby Pert Voice enables different bodies and public authorities to monitor media, TV and radio. Now, live captioning is a market area that is composed by all the activities facilitating language access, live debates, but also recorded ones. And a contact center is the market sector where voice recognition is an enabling feature in order to streamline and facilitate the interaction between the company and the customers. So, for instance, a telephone conversation as a natural language is transcribed in real time and is interpreted by natural language processing programs, thus implementing a number of features that really streamline client management and client and corporate interaction activities. So Pert Voice is a technological company. Research and innovation are the core business of the company. We cooperate with the research centers, economic bodies, institutions, and of course they all are an excellence of excellence in the international marketplace and the stage. And I'd like to mention the European Parliament, a consortium of Italian companies led by Translate, but including FBK and Pert Voice, has been entrusted with the transcription, the machine transcription of parliamentary debates. But humans are still at the very core of the process. As humans have to manage all these nuances of the spoken language that machine and nor IE devices can manage. We work on 30 languages with over 50 language models. That's very important. Fully proprietary technologies allow us to specialize and to customize our services. We could, on one side, develop a vertical system for the radio system or for broadband activities, but we can also customize our services and products to the healthcare, media, institutional context, because the technology is a proprietary one. Let's have a look to a handful actually of use cases of these and MT technologies. The examples I will be showing you are real sort of simplified examples. But as a matter of fact, the needs that are met thanks to these technologies are many, like real-time verbalization of municipal council meetings shows that man-machine mixed performance allowed us to churn out a very reliable product. We wanted to go beyond disabilities and to allow disability bearers to really participate to the life of their municipality as full-fledged citizens. And in order to do that, we've set up a solution that we call PSV, Pert Voice subtitling workstation, that is installed at the client's place or home, which has yielded very good results. But during a municipal council meeting, the audio is taken on board, it is transcribed. Upon the transcription, subtitles are generated, and the subtitles are checked by a human being correcting the captions in order for the captions to be published on a web streaming system. Now, the machine transcription guarantees 95, 96% accuracy levels. But having said that, humans are covering the 3-4% error rate that allows corrections and allow the product to be fully understandable. This is a prerequisite of this type of solution. Using or not using negative expression or a negation at the beginning of the sentence radically changes the meaning of the sentence, and that has to be overseen by a human. And we can also solve extreme situations if the speakers is not understandable, if the audio is bad because of background noise, the human operators only has to listen to the original and dictate to the machine. The dictation is transcribed, double-checked, and then released in the form of captions or subtitles. And subtitles are made available in 4 or 5 seconds on average. And that, you see, it means that it's almost real time. And I have a very short video, which is a piece of evidence of the level of quality and accuracy that we've reached. The single programming document is a very crucial document as it gives information to citizens as to the strategic and operational goals that we've given ourselves. You've seen that a sign language interpreter was also there in a small window. Pert Voice pays a lot of attention to the different needs and requirements. Upstream in a picture-in-picture mode, we were asked to insert the possibility to have sign language interpretation, which is precisely what we've seen during this short video. Now, the second example I'd like to show you is related to a project where the prerequisite, or rather the requirement, was to provide cultural institutions which hadn't got enough ways and means to do them autonomously to enrich or to create technical data sheets related to the items and artifacts that they were showing. So we've implemented a horizontal multi-service platform in a digital ecosystem, enabling transcription, subtitling, translation, voice synthesis. Those were 4 workflows that could be used in different contexts, like the creation of audio guides, transcription of audio-visual content, and indexation for search goals and aims, and many other functions and features that might sort of produce accessible output, both in terms of audio and video. And here again, I'd like to show you a very short demo spot. I really would like to show you what this platform can do for different bodies. So these are the 4 workflows that are depicted, and within each workflow, there is a number of processes. And each of these workflows has been used in different contexts. Now, that's a transcription job, let's say. You see how a digital, rather submerged digital content is first acquired, transcribed, and put in synchrony with the original audio and video. That was a huge simplification for our customer. You can get a text started from an audio bit and to insert this text in a technical data sheet and eventually in a search engine. Well, having said that, I'd like to give the floor to Filippo, who's going to tell you about machine learning. Thank you very much. I too will try to share my screen. First of all, thank you very much for the invitation. I'm Filippo Tessaro. I'm a machine learning engineer. I'm working in Pervoice. I am busy with research and development of new technologies. I apologize, says the technician, you're not sharing your screen. Apologies from the speaker. Here we are. I hope you can see my presentation. Well, I am busy with research and development of new technologies in the field of machine translation. I'm here today because I'm a former student of the Trento University, but also as an employee of Pervoice, and also because I wrote my dissertation from Trento within Pervoice, and in my dissertation, I dealt with real-time spoken machine translation, a system allowing to translate natural speech in real time. Translating in real time is a very complicated task. And it's a kind of task that cannot only be performed by machine translation. Machine translation translates a written document into another written document. Here we have many more variations. There is automatic speech recognition. There are factors such as time, latency, and the visualization of the translation, and that has to happen in real time. So I made my apprenticeship in order to write my dissertation, in order to integrate machine translation and the speech recognition functions by Pert Voice, and putting them together and sort of make one out of two separate things. And I came up with a modular solution that would be an intermediate solution between automatic speech recognition and machine translation, and being able to optimize the latency, which is natural between these two universes. So throughout our IE methods, I developed a way to translate speech, natural speech, almost in real time. That's a demo of the system I developed. It's still a beta test. We're still working at it. The research activities will go on for some time. And that is the demo. Well, the system is tuning up. And as you see, the translation appears in real time. Well, you see that two gray boxes depict the sentences translated, well, the source and the target. Well, of course, sentences keep changing. There's a machine learning algorithm that tells the system where the sentence has to be stopped and when it has to disappear from the screen. The box is empty and then it fills up again. Well, the demo aims at showing that the system is a real-time one, and in Pervoice, we're working for further development of the system together with the other Pervoice systems that might be integrated in the whole of the Pervoice ecosystem, providing support to the final user in order to change the final results, such as, for instance, editing the translation in case of errors, but also to change the quality or improve rather the quality of subtitles. And that's it. Thank you. I'm done. Yes, I'm through. Well, thank you. Thank you very much. Okay. There are some questions. We're in a little bit of a hurry, but there's a question about the subtitling workstation by Pervoice. When you use this product, is there a risk speaker available in order to solve problems if machine recognition is not good, if there is background noise or errors or whatever? And the second the second question is whether it is possible to use a double cursor. If it is possible to edit or change the text that has already been transcribed. As far as we're speaking, well, it is an option. The feature can be enabled within the platform, and of course, is there or can be inserted in order to correct errors due to background noise. Well, you must take into account, always bearing in mind mind that the models, which are the very basis of the transcription activities, are specialized, and the setup phase is there to guarantee the best automatic transcription performances. As a live editing operator, only has to deal with the live post editing of the main corrections, punctuation, gender, plurals, whether or singular, etc. I do have a question as well. Maybe you've mentioned that, but I'd like to know whether there are demo versions. Well, just in case some of our attendees are interested in trying these systems, you said that it is possible to customize these systems and to adjust them to specific needs. At the moment, we have over 380 people attending the meeting, and they're very likely to have sort of different interests and to work in different contexts. Is there a way to take contact with the company? Well, you can definitely contact me. I'll provide my email address in the chat. Well, the orchestration feature enables live captioning and subtitling, but it is possible to do batch subtitling, which is matched with half-assisted post-editing. So subtitles could be supervised and monitored or double check through a web service. Within a specific specialization, it is possible for the user to add specific terms, terminologies, whether it is acronyms, names, or whatever interesting terms, and the machine can be trained to recognize this set of specialized items. Or we completely change context, we completely change the field of specialization, and in that case, we have to adjust the setting to that. Well, I thank both of you very much. Well done. I'm sure there's a lot more to say, but we are running out of time. Please write your questions in the chat box, and you will certainly get an answer. We have a guest from Mainz Germesheim. We have a guest with a small delegation from the Mainz Germesheim University. We have Moritz Schaeffer. He's going to tell us about error recognition during post-editing, which is, of course, very interesting for all translators, to say the least. Moritz Schaeffer's, very briefly, but you have everybody's bios on our site, has translation study specialization. He has worked in Copenhagen, Hamburg, and also in Tokyo. He is a senior research associate at the University of Gutenberg University in Mainz, Johannes Gutenberg University in Mainz, where he's a senior research associate of the Faculty of Translation Studies, Linguistic and Cultural Studies. Please.
Thank you ever so much for that kind introduction and also for the invitation. I'll move on quickly to the presentation because obviously we're running out of time. So can you see my screen? Is that all right? Okay. The topic of my talk is error recognition during post-editing, and at the center of the studies that I'm going to present is the human translator and how the human translator interacts with the machine translation systems at the DGT, the German department of the DGT in particular. So what is error recognition? During word recognition, which is a relatively fast process often, so within, on average, 250 milliseconds, we are able to understand a word on average. So within these 250 milliseconds that we need in order to recognize a word, a lot of things happen, as I said, and that process is helped by creating expectations. So prior context creates expectations and predictions which are top-down. So the translator, when reading a source text, has expectations about the upcoming words, and these interact with what the translator or the reader actually encounters. So the bottom-up processes interact with the top-down processes. And these processes are obviously extremely fast. And of course, if the translator encounters or the post editor encounters an error in the machine translation text, then these expectations are contravened. And so error recognition and predictions that a translator or post editor makes, and the time course of these processes tell us something about how automatic these cognitive mechanisms are. The actual error type of those processes. So if different error types have a different effect on the behavior during post-editing, that tells us something about the underlying processes. And the first study I'll present is a corpus study. The DGT kindly, the German department of the DGT kindly provided us with a relatively small corpus of translated texts, so post-edited texts, together with also the revisions that took place at the DGT. The corpus consisted of 24 texts, 902 segments in total, which became 15,000, a little over 15,000 tokens in the NMT output. And I should say this is the system from 2019, late 2019. Yeah, so roughly we had 15,000 tokens of the MT and the post-edited versions of those same texts. And we then proceeded to annotate these post-edited texts, first in an automatic annotation and then a manual annotation. We used Hierson, a script by Maja Popovic, which automatically identifies errors, so it compares the post-edited text with the original MT output. And then we proceeded to further annotate these automatic annotations manually, and we used the standard MQM, which might be familiar to you. So Hierson, the script that Popovic produced in 2011, identifies inflection errors. So if, say, the verb ending is wrong and the post editor corrects it, then this is identified. Word order, I don't think I need to explain that. Missing words, so if the MT misses words, extra words that are introduced by the MT system, and lexical choice. And so here you have the results from a study from 2017 by Doral and colleagues. And you can see very clearly that, for example, for English German, you get quite large improvements as compared to the statistical machine translation. So NMT reduces reordering errors, inflection errors, to a smaller extent lexical errors. These are results from 2017. A lot has happened since then. But again, this is what we found in these 15,000, roughly 50,000 tokens in percentages. So the largest amount of errors were produced by sort of using wrong words, so actual lexical errors. Reordering was a small problem, missing words and inflectional words disappearing. Extra words were a little bit of a problem, but we combined extra words and lexical errors into one category and only annotated these two categories that Gerson produced. MQM, or the version of MQM that we used, we looked at mistranslation errors, so clearly where the lexical item was simply wrong, terminology errors, which can be conflated with mistranslation, because it's of course a question when a term starts to be a term and when it is not a term. The idiomaticity we included as a category. Register, so style errors. And here we looked at words which essentially mean the same thing, but so as synonymous. And the reason for the post-editor changing this word, we assumed that this was to do with style. Spelling errors, I don't need to explain, and function words were simply something like prepositions, articles, and those kinds of words. And so here you get an example. The source text was a nutrient surplus represents a potential loss to the environment. And now the NMT system, the e-translation, we had a presentation this morning, produced a preposition in German, which is für, back translated into English is for, and the post editor changed it back to the preposition that you can see here, an, which back translated is to. So a small change, and this is the kind of function words. So we classified this change that the post editor introduced into the NMT as a function word. Register errors. So the source text was without aiming to be exhaustive. The links below provide an overview. The NMT produced something that you see here, which back translated into English is something like exhaustive, and the post editor then changed it to complete. So you can argue that exhaustive and complete mean essentially the same thing. So we classified this correction, this error, as a register error. Mistranslation and terminology, we conflated these two simply because it is not always easy to differentiate what a mistranslation is and what a terminology error is, and combine them into one. And so in this case, the source text said the files are prepared in such a way that individuals and so on. The NMT produced bearbeitet, which back translated into English is edited. The post editor produced erstellt, which back translated is created. So again, here, this is not just a question of a synonym, but it's actually a different meaning that is introduced here. I disregard the other errors because they were so rare that they didn't pose a problem. So these three error categories we have here. So nearly 60% of all changes that the post editors, these highly trained translators of the DGT introduced, were register errors, function words, and mistranslation or terminology errors. So with these three error categories, if we conflate mistranslation and terminology, we covered basically nearly 100% of all the changes that the post editors introduced. So rather than us defining what an error is, we took actual data produced by highly trained professionals at the DGT in Brussels and Luxembourg, and classified them in order to get a sense of what happens there. But now our second question was, how are these errors recognized? And for that, we carried out an eye tracking study, which I will present now. And in order to do so, I need to introduce you, in case you are not familiar with the eye tracking measures, the eye movement measures that are commonly used. So when we read text, our eyes are temporarily relatively fixed, and we call these moments in time fixations, represented here as dots. And so in this hypothetical example, you can see that the first fixation is on the second on night, the third on attacked. Then this the is not fixated, is skipped because predictions of prior context make this possible. And then we have a fourth fixation on windmill. And if we look just at the reading times for windmill, this first fixation on windmill represents the first contact with that word. As I said, on average, these first fixations are around 250 to 300 milliseconds, but we get, in this case, a second fixation on windmill, number 5, which means that this word is slightly more difficult than, for example, night. And the sum of these two fixations, number 4 and 5, is what we call a gaze duration. So it represents a later process in the word processing of this word. Then we get a regression to attack, maybe because the reader wonders why a knight would attack a windmill. From number 6, we get a third fixation on windmill, number 7 here. And the sum of these 3 fixations is what we call total reading time. So during translation, you can get something like 20 fixations on a word. During normal reading, that is less often the case. But again, this total reading time is the latest stage in the processing of this word. And so if we look at these different measures, the earliest is first fixation, then gaze duration, regression path duration. I did not explain in too much detail, so let me just go back. The regression path duration is the time that passes between the first contact, if a regression occurs, number 5, 6, and 7, until the eyes move on to the right. So the reader might here wonder, windmill and attacked, why would you attack a windmill? Yes, actually, this is somebody attacking a windmill and moves on. So there's a problem in the integration of the information. The regression is there to solve that comprehension problem. And so the regression path duration is a later process. And now a first fixation allows very little control over what goes on. So the control increases the later these processes or these measures are. In the eye tracking studies, we had 30 participants from the DGT, from the German department, and they were asked to read and correct errors in single sentences. We prepared these sentences so that only one error was present of the ones that we had found in the corpus study, and we corrected all other mistakes that had been present in that particular sentence. In total, we had 81 sentences. As I said, they were produced by the NMT from 2019, the e-translation that you've heard about, and we introduced 19 function error words, 41 register errors, and 21 mistranslation or terminology errors. We had more register errors because our hypothesis was that fewer of those errors would actually be recognized. And that is why we increased or doubled the number of those kinds of errors in the stimuli that we presented. So our hypothesis was that function errors would be recognized early, so possibly during a first fixation duration, especially because they contravene low-level grammatical aspects, and so assumed that these would show up early. Mistranslation and terminology errors we assumed would only show up in later stages of the process, mainly because, of course, you need to integrate the meaning of the source text with what happens in the target text. So a lot more context is required in order to determine whether this word that the NMT produces is actually correct or not. And register errors, again, we assumed that these would be fairly late in the process. Obviously register errors it is not necessary to compare these to the source text necessarily, because of course the choice between two synonyms can be solved monolingually. So the way we implemented this experiment is we presented identical sentence frames. So here you have the German, I'm not going to read it, but the critical word was in this case erschöpfend, exhaustive in English, and an identical sentence with the correct word as it had been corrected by these highly trained professionals. And so participants had 4 possibilities. Either they were presented with an error and actually corrected it, or they were presented with an error and did not correct it, or they were presented with a correct word and did not actually correct it, or they corrected a correct word. So I hope this is clear. Essentially, what we then compared were the reading times on those sentences where we had presented an error and this error was corrected, with the reading times on the sentences which had the correct word and where they were not corrected by the post editors. So we excluded sentences where participants did not correct the errors, or where they corrected correct words. I hope this is clear. And these are the results. So this is the first fixation duration on average. In blue, you have, where's my mouse here? In blue, you have the words that are correct and that had not been corrected. So this is all good. And you can see that function words register errors and mistranslations for the correct words. There's no difference. And in red, you see those words that were wrong, so the errors that we presented and which were corrected. And these are the reading times, the first contact with a particular word in otherwise identical sentence frames. And you can see that if there was an error present and if it was corrected, the first fixation duration increased by something like between 37 and 66 milliseconds. So within something like 300 to 350 milliseconds, these participants were able to recognize that there was actually something wrong. We hypothesized that there would be a difference between the different error types. But as you can see here, I mean, this is a little bit lower than the other two, but statistically, these do not differ. So these participants, these highly trained participants, did not make a difference between function words, register errors, and mistranslation errors in a first contact. So all of these errors are equally important for these highly trained professionals. And I need to stress that this first contact, look at it's a very short amount of time. So a lot of the processes that occur during these 300 to 350 milliseconds are fairly automatic. And again, it shows that these professionals are highly trained. This is a slightly later stage in the processing. So you remember the first pass duration or gaze duration also is the first contact plus any other fixation that occurs on that particular word before moving on to a different word. So you can see the reading times, particularly for the error words, increase slightly. And again, we have no hierarchy. So function error words, register errors, and mistranslation are treated exactly the same in also these later processes. Again, these later measures regression path duration, we get exactly the same picture. So again, we see a difference. So if there's an error, we get a longer regression path. So people go back in context and come back to the actual error word. But even though you can see differences here, they are not statistically significant. So the difference between the red line and the blue line for function error words, register error words, and mistranslation error words is exactly the same, statistically not different. This is the total reading time. So again, we would expect here differences, and there are numerical differences, but they are not statistically significant. So the total reading time, again, that's the sum total of all fixations on a particular word, is statistically not different. The only place in these traditional eye movement measures where we found a difference is in the reading times on the aligned source tokens. So if you have a preposition that is aligned with a preposition in the source text, we look at the reading times in the source text, and here we find an effect, a significant effect for function words. So the source tokens aligned to the function error words are read for longer if there's an error present. For register errors, this difference was not significant, suggesting that these problems can be solved by merely looking at the target text. And mistranslation led to significantly longer reading times in the source. So this is the only place in the traditional eye movement measures where we found a difference. So these were our hypotheses, and unfortunately, we had to spin these. So these highly trained professionals do not make a difference in their automatic or fairly automatic processing of different error types. Everything is treated exactly the same. Everything is recognized very early on, and there's no hierarchy. So we can say that the predictive processes in these participants weigh very heavy in their processing of machine translated text, and the top-down processes are highly tuned to the task. One small effect we found in the I-key span. The I-key span is analog to the décalage or the ear-voice span in simultaneous interpreting, and it describes the time between a first contact with a word and the first keystroke that contributes to the production of a particular word. So analog to what you see in simultaneous interpreting. And the I-key span tells us something when post-editing or also translation about the certainty. So if a translator is very certain that this word that they have just read needs a corrections, they will do so immediately. If this time takes longer, then presumably because they need to check and verify this initial suspicion. And these are the results for the effect of the first fixation duration. This is log transformed. So I've produced here the back transformed values for you. Here we have very short first fixation durations in the region of 100 to 200, 300 milliseconds. And here we have very long first fixations in the region of 3000 milliseconds. And this is the I-key span, also log transformed. So you can see if there's a very short first fixation duration. So if the translator, the first contact with a word is very brief, then relatively so the correction of that word takes a long time. If the first fixation duration is in the region of 3000 milliseconds, then the correction is immediate. But this relationship is only there for function words and mistranslation words. So blue and green are function and mistranslation. For register errors, there's absolutely no effect. So this first contact where sort of the first meaning hypothesis is established has an effect for function words and mistranslation words, but not for register errors. So this is the only place where we could really see that these translators made a difference between register errors and the other types. So we can conclude that the dangers of NMT are primarily that the errors are hidden. Register errors are difficult to spot. There's a number of studies showing that that is a problem, and we've confirmed that. But 60% in our study were actual register errors, so that confirms this. However, if we look at the 30 translations of post-edited versions that these translators produced in the eye tracking study, only 18% of the register errors that we introduced were actually corrected. So there's very little agreement on what constitutes a register error. For mistranslation and function errors, the percentages are quite a bit higher. And as I said, these highly trained professionals did not make a difference or very slight differences in terms of the error types. And we saw small effects concerning the I-key span. So what we recommended to the DGT is to stress the hierarchical importance of errors, both in terms of how they are processed and how they're corrected. So our recommendation was that time could be saved by reducing the number of register errors that were corrected and maybe placing less sort of importance on those errors. And this could also lead to reduced cognitive effort. Now, we did a follow-up study, which is actually not yet published, so you'll soon see it in print as well. We took the 30 translations that were produced during the eye tracking study and calculated the probability that a particular NMT output was corrected. So if it is close to 0 here, then nobody corrected it. And if it is close to 100, then all of our 30 post editors corrected it. So this is the probability on the horizontal axis that the error is actually an error, as determined by these highly trained experts. And we gave these sentences in very much the same way that we did the eye tracking study to our students. So these are the experts. We call our students experts in this case, and gave them two versions. So the blue line is the correct translation, and the red line is the error that we introduced. And we told our participants, these were 20 students and 20 non-students. So these were monolingual German normal people off the street, essentially. And we told them that these were translations from different languages, and they were asked to read those and answer comprehension questions, and simply read them. And what you have here are the reading times on those error words. So you see our students make absolutely no difference, no statistically significant difference between the correct and the incorrect words. And if we look at the data from the lay people, so the people off the street who read those sentences, for the mistranslation errors, they do not spot those. So whether it is correct or incorrect does not make a difference to them. But the register errors, you clearly see a difference between the MT, so the incorrect register, and the correct register. So for the correct register, the reading times are smaller. So in sum, we can say that the interaction between the human and the NMT, as produced late 2019 at the DGT, is a highly complex, fairly automatized in those human translators. And our prior recommendation to reduce the effort spent on register errors needs to be revised in light of these results. So obviously, mistranslation is very difficult to spot if you don't have access to the source text, which in this case, these readers did not have. But register errors make a significant impact on the reading times of those who actually consume those translations, so the lay people off the street. And I think I will stop here, but I'm happy to answer questions.
Thank you very much, Moritz. An extremely interesting presentation and also a very dense and technical one. So I have a comment. As a professor, I am glad to hear that register errors play a very significant role, because register errors are very difficult to teach. We have to work hard on those with our students. And I think that as you grow in age and as you develop more experience, you become more capable of handling them, whereas our students who are still young, they have a tendency to make register errors because they still lack a total ownership of their mother tongue. They enroll in university and they think that their mother tongue, they just have it. But and they think that we each have control, that everyone has equal control of their mother tongue, whereas we know very well that a trained translator, a professional translator, will have better understanding also of her mother tongue after a number of years of working. So from this point of view, I think that the results of this study are important because they empirically prove something that we as trainers know very well. We call it the register problem in while we teach. I do not know if as a researcher and a lecturer and professor, you've had a similar experience. Prepositions are easier to correct in students.
So I think so this is sort of, these results are on the basis of the MT system at the DGT from late 2019. And we all know that MT improves very fast and significantly. So it is very likely that mistranslation and word order will become a thing of the past. So these very fine differences which might still take quite some time to be resolved by the MT systems, the human input is extremely valuable and requires a huge amount of training. You're absolutely right. We also collected data from students for this data set and are still in the process of analyzing this. So I will be able to tell you more directly how students compare to these, and I repeat, highly trained professionals. We did another study where we compared students and professionals correcting errors that had been produced by humans. I don't know if we sort of where the time is, so I could show some more results, but we do find these differences and they are quite interesting. So in particular, in this one study, we found that the professionals corrected the mistakes merely or mainly on the basis of the target text, and only sort of went back to the source text if there were sense errors, so mistranslation errors. The students went back to all, for all kinds of errors, they went back to the source text. And this was very evident in that study that we published a couple of years back. So yeah, I mean, training translators is of course changing. They need to learn how to interact with machines, and the competencies that we taught, say, 10, 20, 30 years ago are not the same that we need today.
Thank you, Moritz. This is extremely interesting. In the chat, a user asked if you could send a list of bibliographic references.
No problem.
Unfortunately, we are running out of time, so we would ask you if you could please reply on the chat so that we can move on to the next speaker.
Thank you.
Thank you very much for your contribution. And now we'll leave the floor to the last speaker of this morning. We are really running late, and I apologize with Mr. Federico Gaspari from the University for Foreigners, Dante Alighieri in Reggio Calabria.
Actually, Federico allowed me to cut short her presentation, and I thank him for this possibility. I want to give him the floor immediately, though, and I think that it really echoes what has been said in the previous speeches, because we are actually talking about humans and the evaluation of the machine translation quality. Well, yes, thank you very much. Let's get the ball rolling immediately, but not without first thanking Professor Sandrelli and all the colleagues of UNINT University, Mrs. Castellani, and the many people who have actually worked in order to make this event possible. And thanks very much to the interpreters whom thank the speaker. I don't want to impinge on your lunch break, and I'll try to be as short as possible. I will be talking about assessment of machine translation, and I will try to cover a number of items as clearly as possible. And then we'll see if there will be time to answer to your questions. I will not go into specific details. I will sort of keep at a general level, but I will be mentioning projects funded by the European Commission, just in order to give you a couple of examples of activities and applications. Many of the things that I wanted to mention have already been said, and in that I was hugely facilitated in my task by previous speakers. But let me tell you something about the main issue with the title of this workshop, which is very timely. Artificial intelligence and machine translation is very much the talk of the day. Machine translation is like a butterfly. It's some sort of a uglish worm at the very beginning, as the first methods that were developed in the 70s or from the 70s on, and machine translation has become the butterfly. But I must say that NMT very often gives us the impression of being very good. Textually speaking, it gives the impression of being absolutely smooth. The output of NMT is rather linear, stylistically speaking, is almost impeccable. It's definitely credible as far as grammar, lexicon, syntax is concerned. As a matter of fact, it very often betrays the meaning of the original language. So it is flowing well, but it is not appropriate, nor it is accurate. There are butterflies that actually takes the shape and color of the environment they live in, and they might look like in this picture, the leaf of the tree. But if we look closely, there are antennas, there are little legs coming out of the leaf, and we see that it looks like a leaf, but it isn't. And if we look at it from a different perspective, from above, for instance, we definitely see that it is a butterfly. It is an insect. We do recognize the different lines of colors. We do as well come to terms with the fact that our first impression was delusional. Why? I used this metaphor, which is definitely going to sound a little bit eccentric, because I want to talk about NNT in the era of artificial intelligence, because there are many optical illusions and delusions as respect to what we perceive, many more than 10 years ago, for instance. At the time, with sort of statistics-based translation, errors were much more evident and simpler to spot. NMT has delivered such a sophisticated technology that errors are disguised in a way. They're hidden, as it happens in for these butterflies or other reptiles, was managed in a way, mixing up with their context, with the environment, and going unnoticed. I have a quote here, very used, maybe abused and known by probably many of you, that I'd like to share with you anyway. We have Yorick Wilkes, a crucial, outstanding researcher in the field of language, philosophy, and artificial intelligence. He worked in Sheffield University for a very long time. His career was extremely influential. He was a pupil of Cambridge's Margaret Masterman, and actually his reputation went well beyond the European borders. I was lucky enough to listen to him and work with him. Well, actually, he wrote an article in The Guardian dating back to 2014. I listened to one of his lectures as a professor emeritus. So if you look for Yorick Wills, you will find a huge number of publications and contributions about artificial intelligence, very provocative, but very enjoyable at the same time. In this very known and very often used quote, Wilkes says the following, and that is the original quote. And I will translate it into Italian, says the speaker. Machine translation evaluation is, for all its faults, probably in better shape than MT itself. Now, please bear in mind that he said that over 30 years ago. Very often, it's much easier to speak or to comment about the evaluation, the assessment of machine translation than enhancing machine translation methods. That is a much more difficult task because there are many variables and many bottlenecks. But there's another part of the quote whereby Yorick Wills declares that we should not change the referee or the rules of the game when we happen not to like how part of the game is going, which is very often applied to politics, for instance. My message, or the message I want to convey, is really inspired by Wilkes' declarations over 30 years ago. Quality as beauty is in the eye of those who really want to see quality, those who want to assess quality with some positive or negative bias. As a matter of fact, and in reality, there are basically two ways to assess MT qualities, which are vastly used today. Well, first of all, automatic metrics. I just posted a limited list of these acronyms, which is actually infested by acronyms. BLEU is one of the most renowned, both in the industrial sector and among universities. The very last is the CHRF. There are different implementation. There is a CHRF3, which is the last version developed by Maja Popovic, one colleague working at the Dublin City University, where I sort of work, and errors and assessment is being developed in a way. What are basically doing all these automatic metrics? They compare the simple output and reference sort of a collection of human translations, and these are the gold standard. Whoever knows something about translation knows that that's a very straightforward, oversimplifying method. Of course, automatic metrics have a lot of flaws. They're very quick, very cheap, and they're extremely useful in development interactions of a system, because I've always used Blow-Nist, Meteor, and many others, but there are others. And I see whether the changes which I embed in the neural system actually do lead to an increase in quality. Therefore, I am able to understand whether I should stop or I should go on with what I'm doing. See, a little bit like working with brick and mortar. It's a very sort of practical, experimental, but nuances escape from our perception. Forcing the coming to play of professional translators, human operators, project managers, etc. I mean, the type of figure that comes in, professional figure that comes into play might change, but still they're human and the methods are manual. I had to draw a selection or to sort of make it screaming, and I only listed 4, and the other ones, well, you allow me to skip them. Here we have sort of a flexible way to run an assessment or an evaluation, allowing the operator to grasp some of the nuances related to quality assessment. But I'd like to follow again Wilkes' quote and its spirit, and I'd like sort of to be provocative and to trigger a critical assessment of the so-called good quality of machine translation. We know that whatever length can be gauged, length, weight, volume of liquids, you name it. But there are different scales and units to measure sizes. Some of this is the conversion table between the metrical system and the imperial one. And that leads me to the main message of my speech. And you're perfectly entitled to disagree with me, as a matter of fact, and maybe we'll have time to start an exchange of opinions, or at least I'll have time to give an answer, provide an answer to your question. Whenever you take the output of a machine translation in order to understand if it's worth, if it is accurate, in the case of an RSP, if it really meets the need of the client, we start from the assumption that we're measuring something, we are gauging something. We can use automatic metrics or with manual methods. So where there are real flesh and blood people coming into play, but measuring is a constant element of these activities. Evaluation is a different thing. The evaluation of machine translation can be done through different methods, little starts, Likert scales, perceived quality, how smooth it flows. Yes, it is, it isn't. Binary choices, box to cross. Here the problem from my point of view, as I will tell you later on, I've taken part in the evaluation and assessment of many commercial methods. Measuring and assessing doesn't necessarily mean or amounts to understanding. And that's precisely why I said since the onset, we're only humans. Okay, we are trying to assess something technical, like a machine translation, but this has to have a point, a sense. you can run assessment, but understanding what works in a system, what is good in the output, what is bad, is more important. What I can do with this method is more important. I very much hope I am being an objective observer, and the very last mile of assessment, understanding what I'm assessing, what I'm gauging, is the most difficult task to perform. I don't have my 30-minute slot, and I really don't want to take time away from your lunch break, but I really would like you to allow me to say that at the ADAPT Center, and Dr. Markens, who will be speaking later on. With the ADAPT Center, we've taken part to a dozen European projects involving machine translation. Yada APTA and ELRI ended. There's one that started in September 2019. The name is Principle. You have the project landing page if you're interested, but approximately, while working on these 3 projects, I and my colleagues are assessing about 100 MT systems, manual or rather quality assessment methods of machine translation. We're doing with many different tools with a very wide range of languages, almost all the official languages of the EU, whether it is Italian, English, French, Spanish, etc., and also minority languages such as other official languages of Spain, and Icelandic or Norwegian, which are outside the sort of boundaries of the EU. And you might remember that at the beginning of his speech, Marcus Forti showed a table of Gaelic or Irish is the second official language of the Republic of Ireland. Within the principal project, we are focusing on 4 of these less supported languages: Croatian, Irish, Icelandic, and Norwegian, Bochmal, as Aspect would say. And I'd like to tell you, really in a nutshell, the lessons learned from 4 human assessment methodologies. So we've involved the translators, interpreters, so the final users in practical terms of these systems. So what do we really need to run an assessment? Well, with automatic metrics, we need a couple of hundred sentence pairs, which could be representative of a certain usage. And then we can use TERP, WER, CHRF, and you name them. There are many, and depending on what you have to do, then you can take a baseline reference. There are online methods which are free of charge, like Google Translate and many others, in order to make or draw a comparison. But still, we are comparing figures. We're not assessing, we're measuring sizes. And my question is, are we really understanding whether the system really works or whether it is good or not? If we want to go beyond the mere measurement and to focus on the real assessment or evaluation of a methods, you can use different ways. For instance, comparison and sort of a listing. You take an input, you give a couple of outputs. One is the system that is being assessed, and then there's a second one which is not being assessed. I would ask the evaluator to sort of draft a priority list, what is preferable, also on the basis of different parameters, usability, clarity, perception. That's simple. It is easy to tell somebody that you have to make an order of preference 5 options. And then the problem is smoothness. On one side, you have the sort of consistency between input and output, and then you have the flow of the target language and how it flows. And that is also a difficult area. Moritz Schaeffer has already dwelled upon post-editing. Post-editing is a bit of a problem. You can take different items, the screen fixation time and many other methods, but that means that as a prerequisite, you must have a given infrastructure. Then there's the error analytics. The error analytics is particularly complicated. First of all, you have to give yourself a taxonomy to classify these errors, which is already easy in a way. But if you have a taxonomy that is called multidimensional quality framework, you can run a mapping, a reliable mapping of the output errors, but it is very cumbersome to apply by evaluators. I don't know whether you're interested, but that is a book that tells you a lot about these methods and many others, which I won't have time to describe. It was published a couple of years ago, and I think that most of university libraries, specialized university libraries, should have a copy of it. It contains approximately 12 chapters drafted by leading thinkers and experts, and I was one of the coordinators. So to go back to Yorick Wilkes' quote, when it comes to assessing machine translation in the time of artificial intelligence, sort of neural networks, please take into account that gauging or measuring is always possible, but that assessing is a different matter. Evaluating and assessing is more complex, and actually assessing doesn't necessarily mean understanding what I'm assessing and what is the core problem. It is very difficult to pinpoint what are the mistakes, what are the most serious ones, and how they should have sort of be put in a ranking or in context. There are still outstanding problems, and there are latest developments that should be underlined. First of all, the level of agreement between evaluators, allowing science to sort of have sort of univocal methods and comparable results. But at the same time, a very interesting issue as far as linguistics is concerned, it's also very interesting for translators, interpreters, and mediators, is that there's a trend to shift from sentence, sentence pair analysis, take a quantum leap and evaluate the quality of machine translation over a whole document. You know very well that very many translation issues are only appreciated at a superphrasal level, going beyond the segmented text. Well, assuming that the good translation or interpretation of a segment of a speech or a document is not enough to appreciate the quality of the whole of the document. And I'd like to underline the DELA system. And it is related to the advantages of appreciating the quality of machine translation over a whole document. It started some months ago, but it's very interesting as it actually puts its finger on a crucial aspect. I very much hope that I've respected the time slot that it was given to me. And again, I thank you very much, especially the organizer. Thanks very much, Federico. Well done. We have, of course, saved some time. So we haven't wasted time. This is not why we're lagging behind. The problem is that all the topics are so interesting. But there's a question for you. Are there official standards for post-editing? And your slides. Can we get a hold on your slides? I mean, not everybody was able to take note of that. Well, I thank very much Desiree for this question. I don't exactly know what you mean by post-editing standards. There's an ISO standard that is related to post-editing as sort of proofreading of machine translation output. This is an ISO standard. I can definitely give you all the references, and I know that some translation agencies and other operators use it. Now, as far as how post-editing should be carried out, well, that's a completely different thing. I mean, I've taken part to sort of courses, professional development initiatives. There aren't many, but of course, what they give you is a general set of coordinates that must be applied to your work depending on languages. For instance, post-editing from English into Italian is completely a different activity as compared to doing sort of post-editing from Chinese to Arabic. So 18587 is the ISO number. You know that the ISO standards must be purchased. I don't exactly know how much this one in particular costs. So I hope my answer to Desiree was acceptable. And I thank very much Bartha Franco, who very much appreciated the butterflies. As far as slides are concerned, well, of course, we cannot send slides and PowerPoint files to all the 350 something people who are attending the webinar. But please go back to the recorded webinar on YouTube. You have all the possible ways and means to stop the video, jot down all the references, etc. I'd like to tell you that you won't find an 8 hours recording. It will be fragmented. It will sort of collect all the different sessions, and you won't have time sort of finding the bit that is most interesting for you. To Federico, I'd like to say, great, well done. The topic is really controversial. And you were very good in telling us that we're only humans, about human intervention is still crucial. All the tasks are changing, and probably this afternoon, during the afternoon session, we will be shown that technology will lead, or the evolution of technology will lead to the reshaping of professional figures. So there's some sort of a hybridation between translating and interpreting. There are mixed professional profiles. We translate from written to speech, from speech to text, etc., with a certain sort of to and fro. But it's very interesting, and I think that there are new job opportunities for those young people who are trying to find a way nowadays. And in order to wind up this morning session, I'd like to ask you for a piece of advice for young people. What should they focus on? Because as a university, we're training them now for a market that is ever changing, and they enroll now. When they will be finished and they will get the university diploma in 3 or 5 years, things will be completely different. So you are a teacher, you know what the sort of gist of the problem is. And I'd like to use some common sense and give a couple of bits of advice. So first of all, I wanted to be provocative. Machine translation is also used in context where it was unthinkable. Biographies, literature, Antonio Torral, but there are even other people, Anna Gerberov and other people between the Netherlands and other countries who are very committed in working to the application of machine translation to literary text. Somebody might have some fierce objection to that, but it's happening. So the fact that machine translation might penetrate sort of consumption literature. I'm not talking about Dante Alighieri, but like lounge literature. And I agree with Annalisa Sandelli when she says the sort of technological bar is put higher and higher. And I keep repeating to my students that in the AI era is while artificial intelligence is progressing, it is really not the case to go backward when it comes to human stupidity. We have to be as effective as possible, more and more effective. But please don't say, this is what I tell my students, so don't say, well, I won't do that because a machine is going to do it in my place. Well, nowadays you need to know more. Those who attend university courses and well, you at UNINT are very well known. I'm an external observer. Has to be future-proofed in the training. And in the very last 3 years, I had the privilege to work in Brussels and Luxembourg with the Italian unit translators about the sort of future-proofing of the profession. I mean, I'm very happy to see that there are so many students here, but at the same time, university curricula must be bold. As your rector said, I mean, the fact of working with different enterprises, with institutions or departments within institutions like DGT is absolutely crucial. webinars, events such as today's are sort of giving students precious hints, but then they have to go forward. I mean, I'm not interested in my students becoming past editors, and I very much hope my students won't be crushed by machines at the end of the day. What I care for translation students is that you, as a professional translator, as a professional interpreter, know about technological progress. So that's the very message I'm trying to convey. So thank you very much, Annalisa, for your question. I very much hope that I provided stuff for thought to your students. Good luck. We absolutely need good translators and good interpreters. And thank you very much for your message. I mean, it's positive, it's full of hope. And I think it sort of soothes the anxiety of people and the students who are just taking a glimpse at the profession and they don't know whether there will be place for them. Well, there won't be place for them only if they translate as a machine. And having said that, on a positive note, we can wind up here, close the morning session, and maybe Katja, you can sort of make the necessary technical announcements. Well, I propose to have a 1 hour break only in order to save a quarter of an hour. So we will resume at 20 to 3. We'll all have time to rest a little bit. I mean, you see that we're too many bits of the information we were bombarded with. Be sharp back here at 20 to 3. The same. Have a nice lunch. Bye. See you later.